Oh, this has been a pleasure but a nightmare. I can't, well, yeah, I can take that off, but there's nothing underneath it. That's the BMS, obviously. I've had to rectify on this BMS the complete mess that somebody else did previous to the current owner. An absolute nightmare it was. I've had to completely strip it down. I've had to replace the main board because that's completely knackered. Oh dear. One thing I'm going to give you a tip about is if you're soldering wires onto these BMSs, take all the bits and pieces, as in this, take it all off first, because otherwise you just can't do it properly. But anyway, the two packs are together. They're not secured together at the minute. I think I'm going to put some padding on this side. There's going to be padding on that side and probably padding on the outsides. There might be some on the bottom, I think I should. So it's basically just completely encased in padding, isn't it, Tony? I've got to put these on. These are going to go on there, and then we have the two main positives. So one goes there and the other one goes there, and then I've got to do all the wiring. Actually, I might do the BMS wiring now. I'll put all this back together and then I'll do all the BMS wiring. I think that might be the best option. Yes, I'll do that first. See, even down to these balance connectors, look, I don't know what the hell's happened there. It looks like they've pulled out and someone's tried to, I don't know, probably solder them back in. Yes, they've been soldered back in, look. What a mess. Sorry, but what a mess. Finally, I've got it wired up. Now, when you come to wire a BMS up, you're not going to have half as many wires as this. This is because it's a fully protected battery. So I've literally got double the wiring, because there's a left and a right and 8 separate cells. 8 parallel cells. Now, when you're testing these BMSs, you get your negative probe, which is the black one, and then you put it onto this terminal here, and then you keep it on there. You do not move it, and then you put your positive terminal on, your positive probe onto that one, and you should get what, 3.5, 3.7 volts, whatever the cell voltage is. Independent cell, and then you put it on the next one, and that should give you the sum of the two cells, and then the next one will be 3 cells, that'll be 12 point whatever volts, and then you keep going up and up and up and up, and it has to increase in voltage each time. If it goes up and then it goes down as you're going along, you've got something wrong. Don't plug it in, because you'll set fire to that. I'm not going to plug that in all the way because I might need to rip it out. Now these things do spark a bit because there's a capacitor, I presume, but this could, oh, I hate that. I don't care. It's only a very small right, here's my power switch, and have we got lights? I don't know where the lights are. Oh my god, it works. Voltages. Oh, I've got the cell count wrong. It's 20S. Oh, it hasn't burst into flames anyway, which is a very good sign, I think. I can plug all those in. I've had to rewire absolutely everything on this. I've had to redo all the connectors. All the connectors not only are crimps, but they're actually soldered. And then we'll fire it up again. What's that? Whoa, 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 stop balancing. Oh, don't say there's a problem with the BMS. Well, it's amazing when you connect all the cells up, it's running. I know what I did wrong. I know what I did, and I know how I did it. Anyway, that's one test done. What happens when it drops a cell? I know that works. That was purposely done. As you can see, we've got a 2 millivolt difference between the cells. I haven't balanced these. It's literally the first time I've turned it on. You can tell I haven't balanced them because I haven't even got the heatsink on there yet. So I'm happy with that. I've still got to put the temperature sensors in, and I've also got to put the main negative wires on there. Amongst all the mess, there's a battery somewhere around here, I think. These are the temperature sensors that go into the battery itself. Now, I've been asked quite a few times how to wire these up. So what you have to do is, your connector here has got 5 wires on it. So you've got 4 temperature sensors and you've got a common ground. So you wire one of them up to that, your temperature sensors, each independent, and then the link has to be on the ground. So what I've done here is, one side of the thermistors, doesn't matter which side at all, because literally all they are is just a resistor. So one side of the resistor, like that, I've attached a common earth, which are all linked together. And then what you do is you then take, I would suggest that you do them in sequence, you know, where the battery is, so you know sort of front, back, middle, and back. I don't know, anyway. So that's what I'm going to do. I'm going to put one there, 1, 2, 3 spaces, one there, 1, 2, 3 spaces, one there, 2, 3 spaces, and then one there to make them all even. I've soldered the negative terminals on, very nice and neat. I'll take this board off first to make sure it's just got the bare essentials on there, so you can't do any heat transfer and knacker anything else. And I use this. This is part of I think it was a 400 watt soldering iron that broke. So I used this and my map gas. You know, needs must. So I've done that. I've tidied the balance wires up. I've got to cover the positive terminals here, just so that nothing touches on it. I've also got to cover the positive terminals over here. Then I've got to tidy this rat's nest of wiring up, which I don't think I'm going to be able to do. I'm probably just going to have to cover it with something. And then I've got to put I've got to tidy this up as well. You see, these are the main terminals, and I've got to crimp something onto the end, and I'm not sure what yet. I don't know what thickness I can get away with. Yeah, we'll have to see. This is the DC to DC converter that was sent to me. It converts, I think they're up to 108 volts, and it'll knock it down to 12 volts constant, regulated. And as you can see, there's not much wire, and this is horrible wire anyway. It's PVC, so I'm going to take it apart and change the wires on it. I've changed the wires in these. Now, you've got to be careful with these bloody things. I mean, number one, they're not actually waterproof at all, and number two, this board, if you pull on these wires, the board will actually pull out. Now, I don't know if you can see, but how the FETs are actually attached to the outside, it's literally a pressure fit with this piece here. Now, what I recommend you do is get a cable tie or something, put it on there, so as when you feed the wires through, it can't be pulled any further out. Because if this starts pulling, the insulator on the back of the FETs is going to come off, and if that happens, it'll short out. So I'm going to put this back together, and then I'm going to wire it up. The other thing that I had to do with this BMS, the bloke who had it before decided to do this mod. This is the mod that I originally did on, I can't remember, but it was to do put a copper bus bar for heat sink. Now, it goes over the balance resistors. Now, this is properly thermal glued. It ain't gonna come off. The bloke who did it actually put just heatsink paste on it and then placed it on top of there and put that on top, and it was floating around everywhere. Anyway, this is properly glued in. It is proper thermal transfer heat adhesive stuff, and it ain't coming off. So I've put the heat pad, the, what's it called, heat sink pad transfer thing, so I can now, if I can find my other glasses, put the last piece on. There's the temperature sensor, which I'm going to put on the top, not underneath, because I don't want it in direct contact with the resistors. I've also countersunk the top screws as well, so as I can well, obviously these will now fit flush. This is now 12 volts out, which I'm going to, I'll heat shrink these properly just to stop any, you know. Anyway, I've tied those together, so yellow is positive, black is negative. These are the charge cables. Obviously red is positive, black is negative, which I've still got to test, so I've just put heat shrink on there. What I'll do is I'll take the insulating tape off, test it, and then I'll put heat shrink over there just to protect it while it's in transit. So I've done that. We've got the power switch, we've got the external buzzer. The only thing I haven't put external on this one is the Bluetooth module. When he bought the bike, he ran it once and then left it for a while, and the batteries were completely dead. Now I could only assume that it was down to this BMS because the BMS itself had bits changed. But having done loads of tests on it, I can't find anything wrong with it. Now, what I think's happened is the BMS has been left on. There's no other way that it could happen. When you put a circuit breaker in, if I was to put a circuit breaker here on these positive wires, literally what it'd do is shut down anything around the BMS, because the BMS runs off these power wires. It's that one, it runs off that one and that one off the battery, so they're always connected. They're not disconnected, so you can't disconnect this unless you take that wire out. That's the main input to the BMS, which is the negative. The only way you could do it is put a breaker there. If you put a breaker there or you put a breaker there, it won't do a damn thing. It's got to be there. So I've now got the screws in. I'm going to fire it up, and then I'm going to test. I can't really test the output too much. I can put a load, something like a 1 amp load on it, but I haven't got anything to actually test it up to its full current, 200 amps. I've tested the output on the DC to DC, that's reading 12 volts, so that's fine. And that's just stuck on the front with Velcro. I've got to test that. I need to get the insulator, as in the neoprene on the outsides and on the back, because this is going to be resting against the case. So I need to get that on, but I need to cover this first in case there's any bits that I need to cover with the side pieces. It's all good fun. Here's the battery. It's in pieces, as you can see. The BMS doesn't work. I'm getting 75 volts on the battery and 70 volts output. I think it's not firing the FETs on the control board, the power board, so I've got to change it. This is another board that I've just tested and it's exactly the same, so I know it's not this board. It's definitely not that. It's got to be something to do with this, which this is the one that I had to strip down and redo because it was all bent and burnt and so anyway, I've got to take the wires off again. I've done loads of testing on it. Current drain, the maximum I can draw with my test equipment is 2 amps and it loses something like about, I can't remember what it is now. Hang on. With a 2 amp load it's losing 5 millivolts, that's it. So 150 amps, not a problem. So there it is. I'm going to pack it up in a crate of some description, I don't know what yet, and get Mr. Courier Man to come and collect it and send it to you, and I hope it works. I don't trust my own work. I think I've got no faith in myself. I'm going to send you some stickers as well. Anyway, thanks for watching. Enjoy life. Bollocks to what anybody else thinks. Before I go, what I wanted to show you was this. This is the power board with all the FETs on it. Basically what happens is the control board or the main board, whatever, tells the BMS to send power. It opens all these things and lets all the power through these C- and B- terminals. Now I took it off and I had a look. I mean, the previous owner must have used a blow lamp of some kind because he's burnt that. Now not only that, but he's heated this up so much all the components have actually come off the other side, and they, I think are to do with the current sense, or maybe I don't know if they're the switch for the FET, so I haven't got a clue, but they've all gone. There's capacitors and resistors and it's gone. Look, gone, totally gone. So this could never have worked, never. Anyway, I changed it. I've got a spare one, so everyone's happy. What a fucking mess that is.